Hello everyone. Today we'll be continuing with our series in which we are solving question from the PRMO 2018 question paper. Today we'll be doing question number 7. In question number 7, it has been said that a point P in the interior of a regular hexagon is at a distance 8, 8 and 16 from the three consecutive vertices of the hexagon respectively. Now if R is the radius of the circumscribed circle of the hexagon, then what is the closest to R? So what we have been given is that we have a from the diagram perspective, we have a hexagon A, B, C, D, E, F. Okay, and then we have a point P, as you can see over here, point P over here. This point P is in the interior of a regular hexagon, and this point P is at a distance of 8, 8 and 16 units from the consecutive vertices of the hexagon. So what we have done over here, we have taken that the point P is a distance of 8 units from A, and then at a distance of 8 units from B, and then at a distance of 16 units from C. So this is the structure that is possible for the point P, which is in the interior of the regular hexagon. Okay, and now it has been given that we have a circumscribed circle of the hexagon. So this is the circumscribed circle, and this circumscribed circle has a radius of R. Okay, and we need to find out what is the integer which is closest to R. So this is what we need to find out. So now let's proceed. So it has been said that the point P, as we have taken over here, is equidistant from the point A and B. Okay, so what we can see over here, that this point P will then definitely lie on the perpendicular bisector of the line AB. Okay, will lie on the perpendicular bisector of the point AB. So as you can see, in that case, any point which lies on the perpendicular bisector is always equidistant from the 2 points A and B. Okay, so this is what we know. So basically this one. Now as you can see over here, in a regular hexagon, if we have such a structure, since O is the center of the circumscribed circle, so all of these triangles, like triangle OAB, then we have triangle OBC, then we have triangle OEF, and all those triangles. If we have total 6 triangles over here, then we have triangle ODE, basically DEO we can write, then we have OCD, and then we have triangle OAF. All these triangles that we have seen mentioned over here, these are all equilateral triangles. Equilateral triangles. Okay, so if they are equilateral triangles, all of these angles, basically every angle which is subtended at the center is basically equal to 60 degree. Okay, and in an equilateral triangle, the perpendicular bisector, angle bisector, median, everything is the same. So as you can see in this structure, the ON is the perpendicular bisector of AB in triangle OAB. Okay, so this ON is also the angle bisector of angle BOA in triangle AOB, or the same angle triangle OAB. Okay, so basically it bisects the angle which it makes, therefore the angle BON which is being made, the angle, so therefore angle BON, this very angle, is equal to half into the angle BOA. Now BOA is nothing but 60 degrees, so half into 60 degrees, so angle, the measurement of BON is basically 30 degrees. Okay, so we have somewhat like this. This is basically OB, and then we have a perpendicular over here, and this is the N, and this is the perpendicular. Okay, and this is 30 degree. Okay, so now we know that OB is nothing but the radius. So what will be ON then? Then ON will be, basically we can write from this very structure that ON is nothing but OB cos of 30 degree. Okay, so therefore ON will be equal to R cos of 30 degree. So what is cos of 30 degree? This is root 3 by 2 into R. This is the structure that you need to remember, that it will be later on used. We need to basically find out the value of r. So as you can see over here in triangle PCO, okay, in triangle PCO you can see that the angle POC is a 90-degree triangle, and if we find out the value of OP in terms of r, then we have OC square plus OP square will be equal to PC square, which we have already been given as 16. So basically we know that OC square plus OP square is equal to PC square. We have PC we have been given, OC also we have been given in terms of r, that OC is equal to r. We need to find basically OP in terms of r, and from that very structure we can find out the value of r. Now to find out the value of OP, we have already found out the value of ON in terms of r. We now need to find out the value of OP in terms of r. So now if we compare the triangles, we have a structure somewhat like this. This is the point P, and then we have right angles over here. So we have PNB over here, triangle PNB, and then we have POC over here. Okay, so as you can see over here, in this case, this side, okay, one other thing that we needed to say is that this PN is the perpendicular bisector, ON is the perpendicular bisector of AB. Now this AB is an equilateral, triangle AOB is an equilateral triangle. Since OB and OA is equal to R, so therefore AB is also equal to R. So that means these individual lengths, that NB and AN, are both equal to R by 2. Okay, so these are equal to R by 2. And we also have, since these are perpendiculars, so we have NB is parallel to OC. We can write that in triangles POC and triangle PNB, we have angle POC is equal to angle PNB, and both of them are equal to 90 degree. Okay, this is one condition that we have got. And then the next condition that we will be getting is that we have OC is parallel to we have NB. As you can see over here, OC is parallel to NB. Okay, so and then we also have angle PCO is equal to angle PBN. So therefore there is a similarity between these two triangles, so therefore we can write that triangle POC is similar to triangle PNB. And from the diagram that we've already drawn over here, we can write that POP by ON is equal to, we can write PC by PB. Okay, and now we know that PC is what? PC is equal to 16. We have been already given that PC is equal to 16. Okay, and what is PB? PB we have been given as 8. This PB, as you have already, it has been given as 8. Okay, so PB is equal to 8. So that means that we have OP by ON is equal to 2. And that means that OP is equal to twice of ON. Now from this structure we have 2 into ON is equal to root 3 into R. So that implies that OP will be equal to root 3 into R. So we have found out the value of OP in terms of R. Okay, now I committed a small mistake over here. I wrote that OP by ON. It is not OP by ON, it should have been OP by PN. So we have OP by PN is equal to 2, and that implies that OP is equal to twice of PN. So we are not getting this structure directly, so we have to write out this portion. It is PN. Okay, so OP is equal to twice of PN. Now as you can see in the diagram over here, basically this point P is also the centroid, and we know that the centroid divides a median in the ratio of 2:3. Centroid. Okay, Now P is the centroid over here. It divides. So we have basically the structure will be now that OP by, we can say, PN is basically, or rather OP by ON is in the ratio of 2 is to, not 2 is to 3, it is rather 2 is to 1. I was mistaken over here. It is 2 is to 1. So OP by ON which we can write as, let me rewrite it. So OP is equal to twice of PN. This is what we know. In other words, we can write as OP will be now equal to 2 by 3 into ON, since it divides in the ratio of 2 is to 1. Okay, so now we know that twice of ON is nothing but equal to root 3R, and then we have 3 in the bottom. So this comes down that OP will be equal to R by root 3. So this is what we know. And now we'll use the Pythagoras theorem that we wanted to use, this very structure that we'll be using. So I can bring it down over here, and by Pythagoras in triangle PCO we have OC square plus OP square is equal to PC square. Now we know that OC square is nothing but equal to R square. OP we have already found out, this is R by root 3 whole square, and PC we know that this is equal to 16. So we have 16 square. So this ultimately gives us R square plus R square by 3, and this is equal to 16 square. So we have 4R square by 3 is equal to 16 square. So 16 square is basically, we'll have, so R square will be equal to 3 by 4 into 16 into 16. So we'll have 12 into 16. Okay, 12 into 16. So this will be basically the format of 2 squared into 3 into 4 squared. So we'll have R will be equal to 2 into 4 into root 3, which will be 8 root 3. And root 3 we know is normally equal to 1.4, 1.5 or some 7 or something like that. So anyways, this ultimately gives us that R will be equal to root over 192. 192, and root over 192, as you can say, is now 14 into 14 is basically equal to, we can say, we have 28, and we have 56, and then we have 40. So we have 196. So the closest number which is nearest closest integer which is closest to R is basically closest integer. And 13 square, we have 13 square is basically 169. So as you can see, 14 square is much more closer to 192 than 13 square. So closest integer will be equal to 40, which is the correct answer over here. So this is how you solve this question. We'll be solving the next question in the subsequent video. Thank you very much.